Introduction to Semiconductor. Semiconductor material is one whose electrical properties lie in between those of insulator and good conductor. Examples are germanium and silicon. In terms of energy bands, semiconductor can be defined as those materials which have almost an empty conduction band and almost five valence band with very narrow energy gap of order of 1 eV, separating the two types of semiconductor. Semiconductor may be classed as under intrinsic or pure semiconductor, extrinsic or impure semiconductor. N-type, P-type. P-type and N-type characteristic. Intrinsic semiconductor, pure semiconductor, no impurity has been added. Example, germanium and silicon. Extrinsic semiconductor, pure semiconductor impurity. This process calling doping process. Two categories of impurity, trivalent and pentavalent. Example, trivalent electrons, aluminium, boron, gallium. Pentavalent 5 valence electrons, antimony, asteroid,
Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Muhammad Mukarrabin bin Tuan Putra. My matrix number is 13 DTK 22F 1056. My lecturer's name is Puan Rasidah binti Siddiq. Today I'm going to be presenting a topic called diodes. There's a lot of interesting facts about this topic, and for today I'm just gonna discuss a few of it. First of all is rectifier. Rectifier use one or more diode, and rectifier cut a half-wave negative cycle or half-wave positive cycle. Rectifier also convert AC to pulses rippling DC. Second is there's three types of rectifier. Half-wave rectifier, and the second is full-wave rectifier, and the third one is bridge rectifier. We move on to Zener diode. Zener diode used to produce a stabilized voltage output or voltage regulator. Second is type of diode that permits current in the forward direction like a normal diode, but also in the reverse direction if the voltage is larger than the breakdown voltage, known as Zener voltage. And the last one is a Zener diode is much like a normal diode, but it is placed in the circuit in reverse bias and operates in reverse breakdown. That's all from me. I hope you like it. Thank you so much.
Assalamualaikum and hi to everyone. My name is Nur Wahida binti Abdul Manah. My matrix number is 13DTK22F1063. The topic given is bipolar junction transistor. I would like to talk about transistor configuration. We have three types of BJT configuration. Among of them are common emitter, common collector, and common base. Common emitter is called configuration, since emitter is common or refers to both input and output terminals. Emitter is usually the terminal closer to or at ground potential. Among all amplifier design is using connection of CE due to the high gain for current and voltage. Two sets of characteristics are necessary to describe the behavior for CE, input and output parameters. The next type of BJT is common collector. Common collector is called since both the signal source and the load share the collector terminal as a common connection point. The output voltage is obtained at emitter terminal. The input characteristic of common collector configuration is provided with the load resistor connection from emitter to ground. It is used primarily for impedance and low output impedance. Move to common base. Common base terminology is derived from the fact that the base is common to both input and output of the configuration. Base is actually the terminal closest to or at ground potential. All current direction will refer to conventional flow, and the arrows in all electronic symbols have a direction defined by this convention. Note that the applied biasing are such as to establish current in the direction indicated for each branch. Next, we move to characteristic. I have included a diagram for reference. Common base is amplifier requires two sets of characteristics: input or driving point characteristic, output or collector the characteristic. The output characteristic have three basic regions: active region, defined by the biasing arrangement; cut-off region, region where the collector current is 0 ampere; saturation region, region of the characteristic to the left. Common emitter for small VCE. VCE saturation, IC increase linearly with increasing of VCE. VCE saturation IC not totally depend on VCE contains IC. IB is very small compared to IC milliampere. Small increase in IB cause big increase in IC. IB is 0 ampere. Noticing the value when IC is 0 ampere, there is still some value of current flow. The last one is common collector. Many BJT transistors use as an amplifier. This is important to notice the limit of operation. At least 3 maximum value mentioned in datasheet. There are maximum power dissipation at collector PC max or PD. Maximum collector emitter voltage is VCE max, sometimes named as VBR or VCEO. Maximum collector current is IC max. There are few rules that need to be followed for BJT transistor used as an amplifier. The rules are transistor need to be operated in active region. IC is IC maximum. VC is VC maximum.